In this question, first we understood the concept. If there is tank which contains the water up to height h, and there is a orifice is here. Suppose PA is the atmospheric pressure here and here. Then we will consider this is a datum line. Suppose V1 velocity is here and V2 velocity is here. Here the density of water we are using, here we are using the density of air. So applying the Bernoulli theorem about this line, we will get PA plus rho H rho of water into G plus half rho of water into V1 square will be is equal to rho of P of air plus rho of air H into G plus half rho V2 square. We know that the density of water is 1000 kilogram per meter cube and density of air is nearly 1.2. So this is too much greater and this is too much small. So we will neglect this. And since this area of cross section is more as compared to this small orifice, so we will also neglect this. Now PA will be cancelled out. So there will be the velocity V2 will be under root 2hg. This is the first phase. Let us consider the case in which there is a liquid filled in a container which has a density 3 times the density of air. So density of liquid, rho of liquid is equal to 3 times density of air. This is the case we are taking. Now the pressure outside cannot be neglected in this case because the density of liquid is 3 times the density of air. So applying the Bernoulli theorem about this datum line, we will get PA plus H rho of liquid into G plus half rho L V1 square is equal to pressure that is outside this of air plus H rho A G. We have to take this because the density of air is comparison with the density of liquid plus half rho of A V2 square. These two will be cancelled out. Since the density of liquid is 3 times the density of air, so this will be 3H rho Ag plus, since this area is larger, so V1 can be neglected. That will be 0. H rho Ag plus half rho A V2 square. This will be 2H rho Ag will be is equal to half rho A V2 square. Rho is a rho will be cancelled out. This is 2Hg into 2 and the root will be V2 and this will be 2 under root Hg is equal to V2. In this question, there is a furnace which is a supply of air to bottom. So here the pressure is A at junction 2. At junction 3, the pressure will be Pa minus Ha rho g. As we know that as we go above from the surface, the pressure is decreased. And this is height h. That's why the pressure is decreased by Ha rho g. Because the density inside the chimney is comparable with the density of air outside it. So we will take the density of air in this case and that will be the net pressure at outside the chimney. Now applying, first we find out the density of air inside it using this formula and density of air after heating is 1 kilogram per meter cube. Applying the Bernoulli theorem at dotted line 2, Pa plus half rho AB square, Pa minus H rho G, which is the pressure at this point, plus H rho G plus half rho V square. So Pa will be cancelled out and since this velocity is negligible at V2 because this has a more area of cross section, so this will be also neglected. So H rho Ag minus H rho G will be equal to half rho V square. So H and G common. This will be 2 rho A upon rho minus rho upon rho, that will be 1 under root will be velocity at 3. Now height is 2, G is 10, this is 1.2 upon 1 minus 1 V3 which comes to be 6 meter per second. Now we will find the mass per unit flowing per unit time dm by dt which will be rho A V. So density is 1. This is pi by 4 into 0.1 ka square. Velocity is 6 which comes to be nearly 0.04712 kilogram per second. That will be 47.12 gram per second.